ordered list, and we can add the elements at one end and delete the elements from the another end. The major difference between a stack and a queue is coming to the stack, deletion and insertion will be done at the single end only, but queue insertion will be done at one end and deletion can be done at the another end. That is a major difference. And coming to the queue, it is called first in, first out. The first element which is inserted, that will be deleted first. So that is the meaning of first in, first out. So this is the example we covered. Just queue. This queue is equivalent to the our data structure queue. Who are in the first position, who are in first in into the queue, that will be the first out person. And at which end the persons will be come out from the queue, that is called front end. At which end the person can be inserted or added to that queue is called rear queue. So if any other person comes, they may add at this position. So this is called rear end. The operations we can perform on QR, NQ, and DQ. NQ means inserting the elements. DQ means deleting the elements. Peak means accessing the elements without deletion. And overflow condition, whenever there is no space is available, even though you are trying to inserting an element, that state is called overflow case. And empty case, whenever we are trying to deleting the elements, but there are no elements in the queue, that is called is empty or underflow state. Where we use queues in our real-time applications. Suppose whenever you are working with the printer, and if you want to take the printouts of the multiple documents, you can observe that whenever first document is being printing, second document must be in the waiting state. So internally for that application, that printer application uses queue internal, queue data structure. And coming to the MP3 player also, if you are working with any MP3 players, if you add the tracks to the player, all the tracks are added into the queue. First added track will be played first, second added track will be played second, and so on. Then types of the queues, linear queue. In the linear queue, the insertion takes place from one end and deletion will place in another end. We covered that point already, and that follows FIFO rule. So this is the example structure for the linear queue. See, these are the elements inserted from the rear. And if you want to delete, you can improve or you can increment the front. Automatically, the elements will be deleted. When you increment this front, the front will point to the next cell. So automatically this cell element will be deleted. Overflow we covered already. And rare increments when inserting an element. Observe this. Initially, this is the rare position. Initially, this is the rare position. And always rare will be incremented and the elements will be inserted. Rare increments when inserting an element, never decrements the value. Coming to the front, whenever front increments, that removing operation will be implemented. Nothing but whenever you increment the front pointer, automatically the elements will be deleted. Observe the structure. Initially, front is at 0th location. When we increment this, it comes to the first location. So automatically, whatever the element available here, that will be deleted. So front increment, deletion operation, rear increment, insertion operation. Remember this. Next, circular queue. So the disadvantage with the linear queue is, even though the space is available, when we increment front, the front comes here again. Okay, this element will be deleted. Whenever front and rear are equal positions or front cross the rear. That means there are no elements in the given queue, but the memory is available. But we cannot utilize that memory. So this is the drawback in the linear queue. But we can overcome this problem with help of the circular queue. The queue is arranged like a circular. That's why it is called circular queue or ring buffer also. Two ends are connected. In the linear queue, we have two ends, front and rear. So two ends are connected. See, rear is incremented. So values are incremented. Whenever we increment front, for example, let us assume that we have the front here and front is incremented up to this point. So these elements are deleted already because we incremented front. So now the space is available. And with help of the rear, we increment the rear. Again, we can store the elements here. So this is how to utilize the space in the circular queue. The next priority queue. So in the last session, we covered already coding part of this linear queue and circular queue also. So let me tell you a few points about a priority queue. A priority queue is an abstract data type. A priority queue is an abstract data type that behaves similarly to the normal queue, except the extra quality what this has is, except that each element has some priority. Every element has some priority. The priority means the element with the highest priority would come first in the priority queue. See this image. For example, we have some elements within the cell. Whatever it might be the elements 1, 2, 3, 4, 5. Okay. But now observe these are the not elements. These are the priorities. First cell element priority is 2. Second cell element priority is 6. Third cell element priority is 7 and so on. So here the lowest number is used to represent highest priority. So this cell has the highest priority. So it comes first to the queue. That highest priority element will be added to the queue first. So this is the meaning of priority. The priority of the elements in the priority queue will determine the order in which elements are removed from the priority queue. So the priority of the elements in the priority queue will determine the order in which the elements are removed from the priority queue. So highest priority elements will be removed first. Okay, because it follows first in, first out. Okay, the highest priority element will be added first, removed first. Now, again, one more type of the queue that is called double-ended queue. This queue is called double-ended queue. Short form is DQ. DQ is a linear data structure in which the insertion and deletion operations are performed from both ends. This is the advantage of this double-ended queue. As of now, we have seen that generally in the linear queue, insertion will be done at one end, and deletion will be done at another end. But coming to the double-ended queue, observe here, insertion and deletion can be done at front end, one end, and deletion, insertion, same two operations can be done at another end also. So this is the advantage of double-ended queue. We can say that DQ is a generalized version of the queue. In the queue, in the linear queue, we have the restrictions. One end used for one purpose and another end is for the another purpose. But in the double-ended queue, we can implement both operations at the both ends. Now, next important data structure is list. As of now, we covered stack and queue. Okay. In the stack, in the queue, we cover different types of the queues also. So we'll start the discussion about the linked list. First, let us start our discussion with the list. What is list? Yes. List is an ordered collection of items of some elements. So you can have any elements. This is a collection. In simple words, list is a ordered collection. Here, the important point is it doesn't mean that the objects are sorted order. Whenever I use the word ordered collection means it doesn't mean it is sorted order. It just means that each object has a position in the list. Every element is maintaining some position. That is the ordered means. This order not indicates ascending or descending order in some position. Zero position, one element, first position, second position, third position. Like that, orderly, the elements are stored in a sequential order, not ascending or descending order. List ADT, as we covered already, ADT means abstract data type. It represents what are the different operations can be performed on a particular data structure. So what are the operations can be performed on list? Traverse. Traverse means visiting the all the elements of the vector is called traverse. Okay. Printing or visiting all the elements in the vector or a list is called traverse operation. Or in generalized words, we can say that visiting all the elements of any data structure that is called traverse operation. Size. It returns the number of the elements in the list. How many number of the elements available in the given list that will be returned by the size. Is empty. It returns a Boolean value indicating whether the list is empty or not. So is empty is a Boolean function. The return type of the function is Boolean. It returns true if the list is empty. It returns false if the list is not empty. It has some elements, one or more elements. The next operation is get operation, get of I, returns the element which is located at the index I. This function is used to get the element which is available at the index I. If the given index value is an out of the range, out of the index, it raises an error. The index must be within the 0 and size minus 1. For example, the list size is 10. Obviously, the index value starts from 0 and ends with 10 minus 1, 9. So whatever the index value we supplied for, for the get method, that must be in between 0 and 9 only. If you write get 10, get 11, that raises an error because that index is out of the bounds. Next operation is set I comma e. This is used to replace the element at index I with e. So whatever the element available at the index I, that element will be replaced with the element E and returns the old element that was replaced. Okay, what was the element we had at the position I? That old element was replaced. That will be returned by this function. An error condition occurs if the given index value is not within the valid range. Next, add I comma E. This is used to insert the element. The previous one is used to replace the particular element, and this add I comma E is used to insert the element E into the list at the given index I. For suppose, if we write the code like add 2 comma 5, the element 5 will be inserted at the index position 2. And here also same thing, the index should be a valid index value that should be in the within the given range. Next operation we can perform on list is remove operation. By the name you can understand it. The remove operation is used to remove and return the element at the index I, moving all subsequent elements one index earlier in the list. So it is used to delete or remove element from the given index value, and remaining elements will be moved in the forward direction by one. And whenever we are working with the remove, the I value should be a valid index value. That should be within the range. That is common property for all operations. Now, let me tell you about vector. What is vector? A vector can be defined as a dynamic array. Already we covered that. What is an array, right? Array is a collection of similar elements that is static nature. Nothing but once you create this array, you cannot change the size of the array. That is a normal point. That is a major drawback of the array. We know that, right? Now, coming to the vector, a vector can be defined as dynamic array that can grow or that can shrink on its own. So whenever you want to add more elements, automatically the size of the vector will be grown. And if you want to delete the elements, automatically the size of the vector will be shrink. So this is the advantage of vector. That's why it is called dynamic array. So dynamically, based on the situation, based on the requirement, the size of the vector will be changed. This behavior is unlike that of arrays, which are static. We covered just now, arrays are static. But similar to arrays, vector elements can be accessed using integer indices. Difference is, this is dynamic array, a static array size cannot be changed. But similarity is how we can access the array elements with help of the index. In the same way, vector elements also can be accessed with help of the indices. So this is the similarity when compared vector to array, a normal array. So this is also in a list. Now, implementation of list. How to implement the list? List is implemented in two ways. One way is using vectors. This vector we can call it as array list also in the terminology of the Java. Vectors are array list. So in this vector, in this, the vector is implemented as a dynamic array as we covered, whose size is increasing dynamically as long as the elements are inserted or added to the list. But here the important point is the time complexity of algorithm is more expensive because there will be more number of shifting of the elements towards left when an element is removed at index I. Observe this point. What we are discussing is, yes, depending on the requirement, the size will be increased or decreased dynamically. That is the advantage. Okay. But now the problem with vector is the time complexity of algorithm is more expensive. It takes more time because when we want to remove any element, all the elements must be shifted to the left side by index 1. Similarly, if you want to insert any element in between the given vector, all the elements must be shifted to the right hand side by one position. So this shifting is very expensive. This shifting task takes more time. That's why it takes more time to execute. Okay. Time complexity is very expensive. Next, the space complexity is also very expensive when working with the vector because the space gradually the space might be increased or decreased. Okay. So that's why also it takes some more time. So space complexity also very expensive. Now, second method. Second way to the implement of a list is linked list. Second way to implement the list is linked list. Then what is linked list? In this way, the elements can be inserted or removed without shifting the elements. This is the advantage. So what are the drawback we found when we implement list with help of the vectors? That can be overcome here. We can overcome the drawback in this linked list. So the elements can be inserted or removed without shifting the elements towards left or right. Thus, the time complexity is very less compared to the vector implementation. So it takes very less amount of the time compared to the vector implementation. And space complexity is not much effective compared to the vector because the node of linked list has two items. One is data, second one is next. So whenever we are working with the linked list, generally we use the word node. Node is used to store the data as well. It is used next node address also. So by the comparing vector and a linked list, we can get the clarity that so best way to implement the list is linked list because that takes very less time and very less space also. Now, what is a linked list structure? How to implement a linked list? Linked list is a sequence of data structures which are connected together via links. So here the one data element can be connected with another data element with help of the nodes, with help of the links. Linked list is a sequence of links which contain items. Each link contain a connection to another link. I will show you the image later on. Linked list is the second most used data structure after the array. A very frequently used data structure in the real time is array. After array, this is second place, second most used data structure. Now, every linked list is formed with nodes. Every node contains data element and link. Data element is nothing but value, and link is used to give the reference to the next node. In the next node, we have the next element. See the structure, linked list representation. First node is always head node. The structure starts from the head node only, and the head node give the reference. Head node give the reference where the node is available. First node. Okay, the address of the first node is available at the head node. And a node, so this is called node. This is a node. Every node contains some data and address of the next node. For example, the address of the third node is 1011. So in the next, we have 1011. Okay. The next part contains the address of the next node. And in the this node also, we have the element and address of the next node and so on. And coming to the last node, for example, if this is our last node, in the last node, in the data item, we have the data, there is no doubt, but coming to the next, there is no next node. That's why it has null reference. It doesn't give reference to any node. That's why that is represented with null, because that is the last node. There is no any another node. As per the above illustration, following are the important points to be considered. So I think the above diagram is clear. Linked list contains a first element called head. First element is always head element or head node. Each link carries a data field and a link field called next. Every node contains 2 points or two things, data field, next field. The next field contains the link for the next node. Each link is linked with its next link, used its next link. Okay. And last link carries a link as null to mark the end of the list. So it is null because there is no any another node. So with the help of the null, we can conclude that that is a last node. There are no nodes further. Then where we use this linked list in real world. Image viewer, for example, when we want to see an image in the laptop or in the system, we may find previous and next buttons or options. So when we click on previous or next, automatically the next image or previous image will be displayed. So to access the images like internally, the operating system uses linked list concept. With help of the linked list, we can move one step forward, next, previous, next only. Then previous and next page in the web browser also. When you work with any web browser, you may find the previous and next options. So for that also that website uses linked list internally. And a music player, whenever you are listening music with the help of the any music player, you have previous and the next options in general. So these options also will be implemented with the help of the linked list concept. So as we covered, we have the different types of the queues. In the same way, in the linked list also, we have the different types of the linked lists. So let us see how many types of the linked list we have and what are the differences among those. First one and very basic one is singly linked list. Singly linked list, item navigation is forward only. So in the single linked list, we have only forward link. So just now we have seen actually this is the single list diagram. Okay, singly link. There is only one link. In simple words, single link means only one link. This is the link node, link no, data item, and second one is link field. We have only one link field in one node. This is completely one node, right? In each and every node, we have only one link, and that link is used to refer the next node. So as we are using only single link, this is called singly linked list. Next, doubly linked list. Items can be navigated forward and backward. So in the doubly linked list, we have two links for each and every node. Every node maintains two links. One link is used to move in the backward direction. One link is used to move in the forward direction, backward and forward directions. Two links. Circular linked list. Last item contains link of the first element as next, and the first element has a link to the last element as previous. The meaning is, as we have seen in the singly linked list, there is no connection for head because this is the first one, and the link is ended here because we are writing now. Okay, but coming to the circular linked list, last link will be connected to the first link again. Okay, I will show you the diagram later on. Just as of now, just remember the definition only. Okay, so that is about circular linked list. Now, what are the basic operations we can perform? Adds an element at the beginning of the list, deletes an element at the beginning of the list, display the complete list, and searches the element using the given key. So these are the operations we can perform. And insertion, deletion, not only at the beginning, we can do at any position. See, insert operation. For example, this is our initial linked list. Okay, this is our linked list. Head node, node 1, node 2. Two nodes we have. And let us assume that we have some data here and we have the reference address of the this node. Okay. Now I want to insert a new node to the existing linked list. How to insert that? How to attach that? What is the procedure we need to follow? Very simple. First, this is our new node. And in the new node, we have the next field and a link field. So attach this link field to the node in the given list. Okay. I want to attach the node here. I want to insert the new node here. Okay. Let us say this is node 1, this is node 3. Okay, because I want to give the name node 2 for this. Next step is you must You must attach the third node address to the second node link position. So this link must give the reference to the third node address in the step one. So already this also giving the reference to the third node. Don't worry, right? Now in the next step, we are going to unlink this. Okay. We are going to remove this link, and now we are going to update the link at the node 1. I want to update the address of node 2 address. Okay. This address will be updated here, and this node address will be updated in the next position. Now you can see that linked list will be like this. Head node, first node address will be attached to the new node. So this node gives the address where the new node is. And the new node link field is attached to the third node address. So finally, it works fine. It creates a new linked list. And we inserted this new node in between two nodes. Wherever you want to insert, you can follow the same procedure. Okay. New node next field must be addressed to the right side node. And what is the node available before the new node? That node link field must be address the new node address. You must follow these steps to insert a new node in any position in the given list, given linked list. Now you can observe the advantage. If we work with the array concept, we need to do more shufflings, right? But we didn't do any more shuffling here. Just we changed the link positions of two nodes only. That's it. That's why it takes very less time. Next, delete operation. How to implement a delete operation? Very simple. Let us say this is our linked list. Okay. Head node, node 1, node 2, let us say node 3. Now I want to remove node 2. Target node means nothing but I want to delete that. That is our target. Very simple. Initially, this next gives the reference to the this address, and this node next give the address to the node 3 address. We know that. Now, first, what I want to do is in the first step, I want to change the address of this node from target node to third node. Okay. I want to update the address here. Which address I want to use? This address. This node address I want to update here. Then this link is going to refer to the this node. Next, what is the link we have from the target node next link? We must unlink it. We must remove it. These steps are enough to delete that particular node. Now, this node doesn't have any connection with this linked list. After that, the linked list will be like this. A linked list with the two nodes only and one head node with the two nodes. Okay, this is a delete operation. Let us see the code for the singly linked list. So this is the code related to singly linked list implementation. Let me cover it uh, part by part, then you can easily understand this. Now see, first we are going to define a node class. Okay, we are going to define a node class. A node is the basic unit of linked list, just now we covered. And each node contain data item, that is value, and a pointer to the next node, right? So to implement this one, okay, this part, I am writing this code. Class, class name is node, int data, because every node contains one data items, na? One data item, one is linked to the next node. So to store the data, I'm taking one data of int type. Node next. So this is the link. It points to the next node. It is the link. It points to the place that is also a node type. That's why that link must be the node type. Okay. Node next. Next constructor to initialize a new node, public node into data. So whatever the data we passed in the code, based on that data, a node is created. So this is used to give the reference for the same class. This dot data equals to data. So in the data, this instance variable, uh, the data is stored, and the this dot next equals to null. So by default, at the time of the creating the node, we are giving the value to the next is null because we didn't set any address. That's why just we are storing the value in the data item. Next, step 2. Define a singly linked list class. The singly linked list class manages the linked list. How to maintain the linked list and what are the operations we can perform, all will be maintained in the singly linked list class. This single linked list class contains methods to insert, delete, search, and display the list. Insert the node, delete the node, search about a particular key, and display the items whatever we have in the list. So to implement all these things, we are creating a class with the name singly linked list. Okay. Then third step, code to insert a new node. If the list is empty, set the new node as head node. Suppose we are creating a new node. There are no nodes available. That is the first node. Obviously, first node is a head node as we covered. So if there are no nodes available, make that newly created node as a head node. Otherwise, means already nodes are available, traverse the list until the last node and add the new node at the end. Traverse means visiting the nodes. So if already nodes are available, we must traverse until the last node and or the newly created node at the end of the existing nodes. For that, the code we are writing like this. Within the single linked list class only, public void insert into data. So whatever the data you want to insert, that will be received at the time of the calling this method. Node, new node equals to new node data. So with the help of the past value, a new node is created. If head equals to null, if the head node represent null, then head equals to new node. Head represent null means there is no node, no node. So new node becomes a head node. Okay. If the list is empty, set new node as a head node. Else, whatever the node we created and stored in the head, that will be assigned to a temporary node. A temporary node. Okay. TEMP temporary is a node type, nothing but temporary node is created. And while temporary dot next is not equals to null, the while loop will be executed if the next is not null. Not null means the link is given to the reference to the next node. If there is a next node, this becomes false. Okay. Temp dot next will give some address. Not equals to null means that is address. So that is true, that will be executed. Then temp equals to temp dot next. In simple terms, if there is a node and the next field is not null, so while condition becomes true and the link will be updated as temp dot next. Nothing but we are traversing from one node to another. When we reach the last node, automatically the while condition becomes false. It comes to the it comes or it exits from the loop. At that point, we are going to add our node. See, tempo dot next equals to new node. A new node is created at the last node. Okay. Now, next step, fourth step, delete a node. If the list is empty, do nothing because no element to delete. If the node to delete is the head node, update the head. Otherwise, find the previous node of the target node and update the link. We need to implement this. Okay. Let me read once again. If the list is empty, no need to do anything because no elements to delete. If the node to delete is head node, update the head. Okay. If you want to delete the head node, existing node and that node is head node, delete that head node and make first node as a head node again. Next, third case. Otherwise, find the previous node of the target node and update the link. So that is what we have done in the update operation. We have seen with help of the diagram. If you want to delete a particular node, you need to update the link of the previous node, right? The previous node must give the reference to the next node of that target node. Then target node will be unlinked. Nothing but that will be deleted. See the code, public void delete int key. So we need to pass the element value or key. So that particular element related node will be deleted. If head is equals to null, if head value is null, then return. So nothing but that is empty. No need to do anything. If head dot data equals to key, then if heads needs to be removed, okay, head will be removed and the node which is available after the head will be modified as a head node. Next, other than these two cases, and we need to check where the particular element is available to be deleted. For that, we need to create a temporary node and we need to traverse from first to the last node, all the nodes. When the particular key is found, then find the previous node and change the address of the previous node. So automatically that particular node will be removed. The target node will be removed. Next, display the linked list. Start from the head node and print each node's value until reaching null. Null means there are no nodes. That is the last node. Public var display node temporary equals to head, while temp not equals to null. So not equals to null means there is another node. So print that node related data and again update the link of the temporary. Nothing but it is going to refer the next node. And again trying to check whether the link is null or not. Not null means then we have one more node also and print the current node value and so on. So when it reaches to the null point, the condition becomes false. Okay. And then it comes out from the loop. When it becomes false, whenever it reaches to the last node, the condition becomes false. If it reaches the last node means all the nodes are covered. So all the nodes value will be displayed. So this is for the displaying purpose. Now search for a particular value. If the particular element is available or not. That search element will be passed. A temporary node is created. Temp not equals to null. And we are going to compare that key value with the data of all the nodes. If found, return true. Okay. Temp equals to temp dot x, that is to go for the next node. Return false in the case of not found. So let me show you the execution. So this is the code as of now we covered because I covered the complete code as a part by part. Then you can understand it easily. Mm, let me execute this. See, linked list after insertion 10, 20, 30, 40 null. Last one is null 10, 20, 30, 40. Okay, four nodes, four data items. Now I want to delete 20. Linked list after deleting 20. The element might be anywhere in the linked list. Okay. After deleting the linked list like 10, 30, 40, null because 20 is deleted. Then I want to search for a element 30. Is 30 in the list or not? Observe this. We have 30 in the list now. Now see, is 30 in the list? That returns true because we have 30 in the list. So still we need to cover some more part of the code. I'll cover this in the next session. So in this, already we covered display part, right? This display function we covered. Search also we covered just now. I need to cover the main method. So what we have written in the main method, how we stored the elements, and how to call the display method, and how to call the delete method, what are the values we passed. Okay, these will be covered in the next session. Okay, right. So before closing this, let me recall what we covered in today's session. We started our discussion with the list concept. In the list, we can implement it with the help of two cases, vector and linked list. Vector is grow and shrink based on the requirement. That is good, but that takes more time. time complexity and space complexity is more. That's why list can be implemented with the help of the linked list. And coming to the linked list, we have several categories. Singly linked list, where we have only single list, single link, and doubly linked list. We have two links, backward and forward, and a circular linked list. The last node link will be attached to the first node again. So the operation insertion and deletion, how we can do that, we covered in this session. So that's it for today's session. Thank you.